Emma, what can you tell me about refraction? What is refraction?
It's when light bends and passing through one medium to another.
Good. So refraction is the bending of light as it passes from one medium to another. So this is most likely going from air to water or going from air to glass or the other way around. That's most likely what it's going to be. It could be other things too. But for the most part, those are the two that we'll talk about and deal with as far as that goes. I find that a helpful visual is this one here, this 2814 one. So the basic idea is you have water, and then you have some light ray, and that ray is coming in. Okay, there's a vertical normal line, just like there was with reflection. And you have this here that's called the angle of incidence. So that's the incoming light. And then you have the angle of refraction. So the light bends at that point. So instead of going straight through the way you would expect it to, it goes through and bends a little bit. And that angle is called the angle of refraction. There is an equation that defines that. We're not going to go into that. Like, we're just looking for the relationship, which is like, does it bend more, does it bend less, or how much does it bend? There is an equation that determines exactly how much it bends, so you can figure that out if you really wanted to. We're not going to need to. You're not going to have to solve that kind of a problem on the final, so I'm not going to spend a lot of time on it. But there is a relationship. I want to make sure you understand, like, it doesn't just willy-nilly just bend however it wants. There's a specific relationship. It's called Snell's law, and that determines how it bends. Okay, so how does refraction work? The basics here is light changes mediums. Okay, when it does so, it bends. Okay, so how does it bend? So this is kind of a thing that is easy to kind of miss and easy to be confused with. The idea is if it goes in from a slow medium, let's refresh it. If it goes from a less dense medium to a more dense medium, it's going to bend to a narrower angle. So just like this here. Okay, so this is going from air to water. If it goes from less dense to more dense, it's going to bend to a narrower angle. So it bends, so what it does, it bends to a narrow angle and going from less dense to more dense. Think of it as it's going to bend it more. Okay, so it's going to bend it more. It's going to get to a tighter, narrower angle of refraction. But when it goes the other way around, it's going to do the opposite. So if it's coming out of the water, again, kind of at some sort of narrow angle. So if it's coming out, well, let's do the same kind of angle I had over here. So here's the angle of incidence. It's going to bend to a wider angle. Again, that angle's always measured from the normal. So even though it seems narrower here, it's actually wider overall. So it goes to a narrow angle and going from less dense to more dense, and opposite when going from more to less. And again, that should kind of make sense if you think about it. So if it's going to go from, well, we'll talk about the reason here in a second. Actually, let's talk about the reason now, because that'll help us make more sense of why it does that. So what causes refraction? What makes it happen? Preston, what makes refraction happen? What's the cause of it? Why? Bingo! What causes refraction? The speed of light changes. That's the big concept here. The speed of light changes. The reason why refraction happens is because the light is going at a slower speed when it enters a denser medium. So when it goes from air to water, it slows down its speed. When it goes from space to air, it slows down its speed. So it goes a little bit slower. And the reason for that is what we talked about with transparency. So when you go from one particle to the next, to the next, to the next, it takes time to do that. So it can't go as fast through the medium as it would have otherwise. Okay? And so that's why you get this narrower, because what happens is it slows down. That goes from going fast, and then it bends because it's going slower, okay? And that's going to make it steeper in the angle. If it's going this way, it's going slow and then speeds up, and that's what causes it there. Another useful visual that you might find helpful, that if you have room or you already drew it, would be this one. So if you're going on some sort of skate or something, part of the skate wheel is going to hit first, and that wheel is going to slow down. The other wheel is going to go at the same speed, so it's going to bend, and that's what causes it to go that way. Same thing is going to happen in the opposite direction. Part of it is going to hit the fast area first. It's going to bend, and then it'll go in that direction. So you can kind of see that here with waves. Here's the direction of the light itself, but light is a wave. So part of that wave is going to hit first and slow down. That's going to bend the overall thing. Okay. Same thing with here, like what Preston was talking about. The denser air is going to cause it to bend, or I guess the less dense air is going to cause it to bend, and that's going to send it up that way. So that's kind of the idea of what's going on with these. Okay, so that's the big thing. You want to understand how it works. Light bends when it goes from one medium to the next, and the way it bends is it gets a narrower angle when it goes from less dense to more dense, and it gets a wider angle when it goes from more to less. And the reason for all that is because the speed of light changes. Okay, any questions there? Perfect. Okay. So let's talk about test corrections real quick. And there's not going to be enough time to get real far on them. There will be time kind of throughout the week if you get done early with stuff. So I'm going to make sure you guys are set up ready to do them today. So that as we go through the week, or when you're done with the test, or if you get through the review guide,